Hello, how are you? Edgar Fernandez from Pharma-Chemical Safety Limited. Now it's Efficient Limited. It's a company that belongs to Pharma-Chemical Safety. So little by little, you're gonna see the new title of this company changing in some social media that we have present. The topic of today it's FIVCs. It's how to eliminate static while emptying or storing combustible powders. Um, the mission of the sufficient company is to protect people's lives by reducing incidents drastically through the sufficient methodology. Um, Myself, as an owner of the company, I have 23 years of experience in process and occupational health and safety areas in the pharmaceutical, manufacturing, oil and gas industries. Currently, I hold the professional engineer designation in Ontario and Alberta, and I hold the CRSP and CSP the designations in Canada and the United States. I hold a bachelor degree in chemical engineering. What is the meaning of the FIVC? What is they call flexible intermediate bulk containers that is used in the worldwide transportation industry? So that's where we transport combustible powders or any type of powder um, in a flake or granulate form. So since many of these products are also combustible solids, or maybe processed in environments containing flammable vapors. So that means that um, you want to introduce these type of materials in the Supersacs in areas that they contain flammable liquids, or you're gonna discharge this material in, for example, reactors that they contain flammable liquids, and it's a lot of flammable vapor inside. So there is different classifications that we want to see. So the inherent electrostatic discharge hazard from handling the material cannot be overlooked. So that's the reason it's important to see this topic of the classification of the super sacks. So these super sacks, that's the way they call as well, super sacks or FIBCs. So typically are made of the woven plastic with some type of a liner insert and are often referred to as super sacks or B packs or bull sacks. And electrostatic ignition hazards are prevalent. So in almost any process environment where material like solid or liquid is being transferred. In these cases of the filling or the discharging. So the refilling or discharging of the supersac, there is a steady accumulation of static that is created because the movement of the material is gonna create the friction or is through the speed of the discharge. And this steady accumulation of static can result on electrostatic discharges that's gonna generate flash fires. And thus this may in turn this may in turn provide sufficient energy for ignition of the combustible particle. So another parameter that we're gonna see later is the MIE. Remember, we saw on the last episode of this combustible powder series, it's the parameter, the classification of combustible liquids, and we see what parameters we need to get depending on the operation that we have, and one of them is the MIE, is to see how sensitive is our powder to static. Not also it's and actually I want to mention is the unsettling shocks to nearby to personnel. I have I have experience on this. There are people that are more sensitive than others, and they can feel those discharges as well. And we need to protect personnel as well against those discharges because they can result in a fatality as well. And has happened in the industry, not often, but it has. Um, and that's the reason why you need to have your static dissipation program on top, because this type of hazard cannot be overlooked. So the proper use of grounding and bounding can be effective in the mitigation of these hazards. Also, the mitigation, that's the main goal of this presentation, is we need to requires to correctly choosing the Supersac, what type of Supersac we want to use, and what type of implementation of bonding and grounding we need to have. The types of the Supersacs, they are determined by the minimum ignition energy. So understanding the minimum ignition energy of your combustible dose of flammable vapor is a necessary component for selecting the correct or the right FIVC. For your application, for the type of the process that you have. So you select the normally the vendors or suppliers, they select the types of Supersacs, but for cost to save money, some suppliers they said so all our powders or our products, they're gonna go in a Supersacs Type C, or they're gonna go in Supersacs Type V, because it's saving money. So and also they handle better and they manage better their combustible powder program, because they have different products that they can go in Type A, Type B, or Type C, or Type D. So to avoid the misunderstanding of the mistake that somebody is putting a very combustible powder in a Supersac Type E instead of Type D, so they said everything is gonna go in Type D. So that's something that you're gonna find when a supplier is sending you is providing you the raw material that it comes in a powder form. So it's very typical that you're gonna find that. So the NFPA, like I said, the 654 is it's the standard for prevention fire of those explosions from combustible particle solids. They provide the guidance on selecting the appropriate type of the FIBC. And on the 2013 edition, they gave the classification depending on or based on the MIE. So it's very important that you have this value, this data as a safety process engineer, because not only MIE not only is gonna let you know how sensitive is your powder to a static, but also they're gonna give you what type of bulk container you need to use. So, like I mentioned, it's very simple. They have 4 types: Type A, Type B, Type C, and Type D. That's the classification from the NFPA 654. And in regulations here in Canada, they follow this NFPA 654. So we need to get familiarized with that standard. The first type that the NFPA 654 describes is the Supersac Type A, that is limited to use with non-combustible particle solids or combustible particle solids having an MIE greater than 1000 millijoules. These type of bags are made of plain woven, polypropylene, and other non-conductive fabrics materials. And the static is generated as the product moves or rubs against the inside surface of the Supersac under the operations or filling operations or discharging operations. Many organics materials as well as chemicals can form combustible clouds, obviously when you conduct this type of operations, and it can be ignited by electrostatic energy or discharges. And it's important to remember that this type of bags they don't offer any static protection, so therefore you cannot use it to transport or any combustible powder, because of the lack of protection of static dissipation. So normally So products that are not combustible, they normally the vendors or suppliers, they use this type of bags. The second classification from the NFPA 654, it's the type V FIBC, and is permitted for use when combustible dots with an MIE greater than 3 millijoules but less than 1000 millijoules are present. And these type of bags are similar to the type A bag, that they are made of the plain woven polypropylene fabrics or other non-conducting materials. Also, like the type E, the type B don't have any mechanism for dissipating static. An added benefit of the type V is that they are made from materials, or sometimes they are made from materials that they have a low breakdown voltage to prevent incidents where highly energetic and dangerous propagating burst discharges occur. So although the type B Supersac can prevent the propagating burst discharges, they call PVD, they still are not considered antistatic because they don't have a mechanism to dissipate the static electricity. So for a bag to be considered antistatic, they must have a reliable mechanism for dissipating static electricity. Aside from the risk of the incendiario having a flash fire incendiary discharges, there are other consequences associated with the non-using an antistatic supersac, such as the type B bag. So they can cause electrostatic shocks to the operators. Although not dangerous, well, although not dangerous, these shocks are very annoying and it can cause other accidents. And but depending on the discharge, actually, sometimes they are dangerous. To be honest with you, and they're having cases. No, they are not often. They are very rare, but they are having some fatalities as well when people suffer those static discharges. And the reason why is because the simple reason is because more people are more sensitive. There are people that are more sensitive to other than others to feel to sense the discharges. But also you have heart problems or hypertension. For sure, this is gonna affect you. So some companies they are playing on the safe side. That is extremely really good. So after suffering a discharge, um, they send the operator or the person who felt the discharge to the to see the doctor and follow some protocols, only to check blood pressure and how he's feeling, to make sure that the heart is okay. Because in the past it's very rare, but it has happened that somebody has died because electrostatic discharge. So, and I have the experience actually. I measure some discharges from different materials, and those discharges can be 300 millijoules, sometimes 700. So it's very important that you have your static dissipation program in place, and you have some devices to measure those discharges as well. Um, uh, in another presentation, I'm gonna talk about static, no, not right now, and what is the minimum millijoules that you need to have for this type of operations and others. So those and other contaminants can become attract to the surface of the bag, so made it difficult to fully empty the bag because of the static. Product can become stuck to the side of the bags because of the static electricity. Um, we don't need so when we don't need to use the Supersac. So between 3 millijoules and 1000 millijoules, for sure we're going to have combustible powders. You see the another presentation of combustible or classification of combustible dust or powders. There is a classification from ST0 to ST3 and depends on the KST. And I talk about also about other parameters you need to measure, and is the MIE. And for sure, under that classification, although it depends on the KST, so you're gonna see the relation KST and MI and MIE. So you're gonna see that very combustible powders, they have very low minimum ignition energy. So for sure, it is gonna be between ST2, ST1, and ST2. No doubt about it. So you use this type of Supersacs type B. Although it's not very recommendable, but you can talk to the vendor, to the manufacturer of your combustible powder, and if you require them to be in Type C that you're gonna see on the next slide, you can do that to play it on the safe side. Or Type D, you don't have. No, sorry, not Type D. So Type C and or the Type V. But the Type V cannot be present. You can introduce a Supersac in an to discharge this powder from the Type V when flammable liquids or flammable vapors are involved. Or you can introduce a Supersac in an area that they have flammable liquids or flammable vapors present. You can't. So that's the characteristics of this Type B Supersac. So we jump to the Type C. So the Type C Supersac is permitted for all combustible dust regardless of the MIE. And also, you can introduce the Supersac in areas where the flammable vapors are present. When flammable vapors are present, I mean when you have an open drum with flammable liquid, or you're gonna discharge the Supersac into a reactor when it has flammable liquid inside, or has residual flammable liquids, or a flammable liquid has been there before, or therefore there are present flammable vapors. But these vapors should have an MIE greater than 0.14. So remember, on the flammable vapors or flammable liquids, there are conductive and non-conductive flammable vapors, flammable liquids. So if they generate those vapors, so the most dangerous ones are the non-conductive, such as toluene and xylene. That is not conduct; they conduct, but they dissipate static so low. And so when you can introduce this type of Supersacs, the Type C. So they're called anti-static Supersacs. And they are made from a totally conductive fabric materials or from a non-conductive fabric containing interconnected conductive threads or filaments. So actually you can see around the back like a grid. So that means the Supersac has been made for a non-conductive materials, but they are introduced these inserts to make the back conductive. So and now you see the yarns. One of the yarns needs to be grounded. For sure, that's the reason why you see those black stripes around, because one of them needs to be grounded. So you should have on your training package of combustible powders, you need to have this type of information, and also you need to stipulate on your standard operation procedure and training package that these type of packs, they need to be grounded. So you clamped when one of the yarns. That means that it's ground and goes to the grounding system. And you can use this Supersac anywhere. So you have present flammable vapors, and you're gonna discharge your combustible powder into a reactor that has flammable vapors or flammable liquid. Can be done, can be used. Type A, not. Type B, no. Although the Type B is between 3 millijoules and 1000 millijoules. And you can have ST1 or ST2 powder, cannot be used in flammable liquids areas or flammable vapors where are present. But the Type C, absolutely. Now, so this the last type of the Supersac that is described with the NFPA 654 is the type D. So it's permitted for use when combustible dust are present or in locations where flammable vapors with an MIE greater than 0.14 millijoules are present. This type of Supersac is not appropriate for use for combustible powders. So another thing, this is very important to notice. So the powder that should be inside of the Supersac shouldn't be combustible. However, you can introduce this type of powders in the Supersac Type D in an environment or rooms when you have flammable liquids or flammable vapors present. So the same is you have on the pharmaceutical chemical operations, you have your reactors. You're gonna discharge this powder. It's not combustible, but it's gonna be involved. It's gonna be in touch with flammable material, with flammable vapors or flammable liquids, and that happens a lot on the pharmaceutical industry. It's the same on the chemical industry as well. So remember, it shouldn't be combustible, but can be introduced in areas with flammable vapors, or if you are generating combustible dust, can be introduced as well. So it's the characteristics of this type D Supersac. So what type of Supersac or FIBC do I need to use? So although the classification of these Supersacs, so the type V has some static dissipation properties, but it's not recommended for combustible powders. So for sure not. So that combustible powders is to use type C Supersac only. So for the rest of the powders, so you're gonna have, for example, you have an area where it's a flammable liquid or flammable vapors present, and your powder is present. The only type of Supersac that should be there with a non-combustible powder is the type D. Supersacs A and B can be introduced in any location where flammable vapors or flammable liquids are not present. And obviously the 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 powder is inside is not combustible. So the only Supersac that you can use for combustible powders and when flammable liquids or flammable vapors are present is a type C. But remember, you need to ground one of the jars. That's the way that you're gonna use your Supersac. So what classification you're gonna use? Well, if you are a manufacturer of combustible powders, so obviously you need to get different parameters on your operation, KST, and obviously the MIE, the minimum ignition energy. For companies that they're gonna use that combustible powder as a part of the raw material, well, it's good. A part of your training package of combustible powders should include this topic, the Supersacs, how you're gonna recognize them and what type of powders they have inside. And but remember, it's depending on the MIE, and on your training package should have this type of information, illustrations, and saying that the Supersac Type C needs to be grounded. So you're on so either way, you need as a part of the NFPA 654 actually, you need to test your powder or dust. And some of the certified labs in the market, obviously they know how to do the test according to the ASTM standards, and some of them they have, or most of them they have experience of operations as well. So they can tell you, they can guide you what type of test or what other tests they don't have, you need to use. Because I'm gonna give you an example. I hired one of the labs before with a lot of experience, in in operations, and they realized there was no combustible powders, but they recommended to do another test um, to determine at what temperature that powder can be decomposed, and that you generate another type of problems inside of your reactors or in your on other type of processes. So that's the thing that that's my recommendation. So test your powders and include this type of information on your combustible powder training package, and teach your operators how to recognize a Supersac, and include under the standard operation procedures that the Type C Supersac needs to be grounded. There is some more videos coming regarding on this topic. I haven't finished these episodes of the episode of combustible powder, because it's so big, so wide, and it deserves each aspect of the operation deserves its own attention, because they have its own nature to deal with, to avoid flash fires or identify any type of hazards when we handle this type of materials. And you can contact me. You have questions or you need more information at 613-464-0562. On the description of my different social media platforms, you're gonna find you can access my Facebook page, my Twitter page, and LinkedIn, my web page, and also I have Google Plus, and I have 3 platforms also on the to produce podcast. So you have an Android phone or an iPhone. So I have in iTunes, and I have in SoundCloud or Pocket Cast. So you can access my material as well. So see you on the next video. Thank you very much. Hopefully this information helped you a lot. The thing that I'm trying is to split the operation little by little, because I have faced this type of problems as well as you, and hopefully my information helps you a lot to protect people's life. That is the mission of my company. So we protect people's lives. That's the most important. How we do it? Reducing incidents drastically by providing this type of training, by providing this type of identification of hazards, and we use the sufficient methodology that not only we take in count uh, this technical or engineering knowledge, but also we include coaching, training, lean manufacturing, now lean safety as well. Lean safety was born from lean manufacturing. So we have a very comprehensive way to look at the operation, not only from the technical standpoint, but only from the human standpoint as well. That is going according to our mission, protecting lives. Thank you very much. See you next time. Bye.